So, good morning, everyone. I welcome you back to my YouTube channel. Presenting before you this wonderful tutorial is the mentor Hamburg Kliman. And if you are new to this channel, consider subscribing, hitting the like button, and don't you forget to share to others. We have yet another interesting question in dimensional analysis where we've been asked to determine the values of n and m. So to those of you that don't know, actually dimensional analysis can come in this particular way and you can be asked to find the values. Those of you that are under my personal tuitions, you understand how to solve values under dimensional analysis. Of course, using the MLT concept, which I've already taught. So we are taught that the acceleration A of a particle moving with uniform speed in a circle of radius r is proportional to some power of r. Say that where you say r is equal to the r to the power n and some power of v to the power m. Then we've been asked to determine the values of n and m and write simplest form of an equation for acceleration. And of course, if you have subscribed to this channel, I taught you how to solve dimensional analysis, especially for objects either in a straight line or in a circular motion. So in this case, the main concept we are using is this particular term that's saying in a circle. So we are applying a certain force called the centripetal force. Let's do the solution. So what is going to happen here is this. This is going to be an object that is moving in a circle. And this object, for this object to continue or maintain in a circular motion, it means there is a certain force which is acting at some point in the middle, okay, defined by a certain radius, which is maintaining this particular object to move in a circular manner. This object is moving with a certain speed, which we can call v, and at the same time, it is accelerating at some point A, okay? And at the same time, because it's a particle, so it's got a certain mass. It possesses a certain mass, okay? If we are to find this particular relationship that is there, we would discover that the force, or which is the centripetal force, which is causing this object to move in a circular manner, is defined by the mass multiplied by the velocity to the power 2 over the radius. Okay, that is the relationship which is taking place here. But we know that the force is defined by MA. So where there is force, I can put MA. Okay, MA is going to equal to mv to the power 2 over r. I can cancel the m and the mass there, and I'm going to remain with A, which is the acceleration, equal to v over r. Now, the question is simply saying we find the values of n and m. Which concept do you use for these particular questions? Whenever you are given a question like this under dimension analysis and you are a student on this particular channel, make sure that you use this particular concept. What is the concept? It is called the MLT concept. MLT concept simply denotes M for the mass, dimensions of mass, L for the dimensions of length, T for the dimensions of time. So in this case, let's find the dimensional formulas of acceleration. Acceleration in the MLT concept, because we know that the dimensions is L over T to the power 2. So in the MLT concept, it is going to be M, L, T. Remember that T, we do not have M, so it's going to be power 0. Remember that we've got L there, so it's going to be power 1. We've got 2, but it's underneath the L, so it's going to be negative 2. Good. We can establish the dimensions of V, or the velocity. Of course, it's going to be L over T. So in the MLT concept, it's going to be 0. It's going to be a 1 there, and a negative 1. Then we establish the dimensions the dimensions, or rather, of radius, we know that it is simply capital letter L. In the MLT concept, it's 0, L, and then T, 0. Okay? Okay? That is how you are going to establish your MLT concept there. Now, what does this denote? What is the significance? I am going to get my formula. A is equal to V to the power 2 over R. Where there is A, I'm going to replace with my MLT concept. So remember, A is this particular guy here. Okay, so I can replace. I'm going to say M to the power 0, then L, then this is to the power 1, then T, negative 2. Good. And then I'm going to replace, where there is V, I'm going to put my M to the power 0, L to the power 1, T to the power negative 2, all over by the power 2. Now, notice we've been told that this V is equivalent to a certain power, which we are simply calling as V to the power M. It is here. So, I am going to get my V to the power M. Okay, so this is just the same as V to the power M, and this is R to the power N. So, I'm going to put my M here. And then I'll say over, and then where there is R, I can replace my M to the power 0, L, then T power 0, all over by N. Okay? So, if I was to do my multiplication, okay, if I was to do, sorry. Okay, let me just wrap somewhere there. Okay, so I'm supposed to put negative 1 there. Okay, so this is going to be negative 1. So if I'm to expand everything, we are going to get M to the power 0, L1, T, negative 2, and then this is just going to be M, 0, like that. Then L, okay, so here, 2 multiplied by 0, it is just 0. 2 multiplied by 1, it will be 2. Then 2 multiplied by negative 1, it is going to be T, negative 1. Like that. Okay, so this is going to be to the power M all over by, okay, this is N to the power 0, so it's going to be M to the power 0. This is L to the power 1 multiplied by N, so it's going to be L to the power N, and then T to the power 0. Okay, then I'm going to formulate equations. Let me start with 0. If I'm using M, what equation can I get? If I'm using M, what equation can I get? So if I'm using M, I'm going to fetch my M here and say M to the power 0 is going to equal to, the top is going to be M to the power 0, okay, M to the power 0, of course, then all over by M to the power 0. So this is my equation 1, which is very irrelevant. It can't help us. Let me fetch the equation for L. I'll say L to the power 1 is going to equal to, which is this L. Then I'm going to fetch my L to the power 2. So this is going to be L. Now, this M multiplied by this 2 is going to be 2M. Okay, all over by L to the power N. This is going to be my equation 2. Let me do C. If I'm using T, let's say T to the power negative 2 is going to equal to, okay, good. We also have T to the power negative 2 here. Okay, so this is going to be T to the power negative 2 M all over by, okay, so anything raised to the power 0 is a 1. So this is over 1. So this can also be written as T negative 2 is equal to T negative 2M. That and that can cancel. We are going to get negative 2 is equal to negative M. If you cancel this side, you cancel both sides, you realize that your M is going to equal 1. Now, how do you find N? You can use this equation. So it's going to be L to the power 1 is equal to L to the power 2m over L to the power n. So this is just the same as 1 is, so we cancel everything. So this is going to be 1 is equal to 2m over n. Okay, so 1 is equal to 2m over 1. We can replace, sorry, okay, so we can replace, so this is going to be 2m then over 1. So this is going to be 1 is equal to 2m, so we can find, okay, so where am I putting, okay, my 1, okay, so I'm replacing 1 here and then n, so we cross multiply, n is going to equal to 2. Henceforth, the equation we are using, so the values of m and n is equal to 1, then n is equal to 2, and the equation is a is equal to v power 2 over r. Okay, that is how you find this particular question. If you found this video interesting and helpful, consider subscribing, hitting the like button, and don't forget to share to others. Thank you so much.